Streamline flow of liquid or fluid. Streamline flow of liquid or fluid. In the diagram we have shown a tube at t equals 0 instant. This is a streamline or line along which different particles of liquid are moving. This is a streamline or imaginary curved line along which different particles of liquid move, and this is the imaginary curved line or streamline. Imaginary curved line or streamline. On the streamline we can denote 3 points A, B and C. At the point B, particle 1 is moving with the velocity vector v1. At the point B, the particle 1 is moving in this direction or along this tangent. Particle 1 at the point B has a tendency to move along this tangent with a velocity vector v1. At the same instant, that means at t equals 0 instant, liquid particle 2 will be moving with the velocity vector v2 along this tangent. Particle 2 will be moving with the velocity vector v2 at instant t equals to 0. Similarly, we can draw streamline. We can draw streamline and we can denote 3 different points A, B, C on the streamline. At instant t equal t second, and at instant t equal to t second, particle 1 reaches to the point C and it has a velocity vector v1 prime along that tangent, and at the same time particle 2 will be moving with the velocity vector v2 prime, and at the point A, particle 3 will be moving with the velocity vector v3 prime. For streamline flow, while crossing the point B, crossing the point B, every particle has the same velocity in magnitude and direction as that of its preceding particle. Therefore, vector v2 prime will be equal to vector v1. For streamline flow of liquid, vector v2 prime is equal vector v1. Streamline flow of a liquid is that flow in which every particle of the liquid follows exactly the same path of its preceding particle. Every particle of the liquid follows exactly the same path of its preceding particle and has the same velocity in magnitude and direction. As that of its preceding particle. While crossing through that point, we can draw a horizontal tube, and this is the imaginary curved line, that means streamline. At the point B, liquid particle 1 is trying to move with velocity vector v1 along the tangent at1. At the point A, particle 2 is moving with the velocity vector v2 along the tangent at2. That was at instant t equals 0. Now, this is the diagram at instant t equal t second, and we can denote 3 points A, B, C. At t equal t second, at the point C, particle 1 has the velocity vector v1 prime, and at the point B, particle 2 has the velocity vector v2 prime. For streamline flow, vector v2 prime is equal vector v1. At instant t equal t second, means at the final stage v2 prime is the velocity, vector v2 prime is the velocity of particle 2 at the point B at instant t equal t second. Similarly, vector v1 was the velocity of particle 1 at the point B at instant t equal to 0 second, at instant t equal to 0 second. Let vector v1 and vector v2 be the velocity vectors of the two particles of liquid at the points B and A respectively on the streamline at instant t equal to 0 second. This is the streamline in the diagram. Similarly, vector v1 prime and vector v2 prime be the velocity vectors of that two particles of liquid at the points C and B respectively on that streamline at the final instant equal to t second. For streamline flow, vector v2 prime equal vector v1 while crossing the point B. While crossing the point B by the particles 2 and 1 respectively at instant t equal t second, at instant t equal 0 second. Streamline flow, that is laminar flow in the form of layers, is regular and orderly flow. Another characteristics of streamline flow is the velocity of liquid flow is less than the critical velocity. The velocity of liquid flow is less than the critical velocity. Next characteristics of streamline flow is what? The value of Reynolds number, not with apostrophe s, for this flow lies between 0 to 2000. Value of Reynolds number for this flow lies between 0 to 2000. The energy is used for the outward motion or outward flow of liquid only as the energy is used for the outward flow of liquid only, and the viscous force dominates over the inertial force.